titled Learning to Predict by the Methods of Temporal Difference. In the first slide, I'm showing two reinforcement learning algorithms between 1 and 5,000 episodes with different alpha values. Alpha value here is set to .1 and alpha value here is set to .001. As you can see in the run with .1, none of the episodes really hit the ideal value. However, when adjusted down to 100th of a point, 5,000 episodes actually achieves pretty darn close to the ideal state. In the second slide, we start to get into Richard Sutton's actual figure. Here's the baseline figure, and here is the recreated results. The results are very similar for the lambda 1 values, although they're slightly different. Again, I attribute that to the difference in training set values. It's a similar curve. The other major difference between the two is that the lower error rates are at the .2 to .4 lambdas. These error rates are lowest among the .6 to .7. We'll discuss a little bit detailed in further slides. Recreation of figure 4. In the case of lambda 1, which is represented in my results, the sharp yellow line, aside from the curves, the data ends up finishing off just under .7, which is very similar here. The other patterns that are very similar are anywhere from 0 to .3, and then from .3 on they vary slightly differently. I threw in an extra value here for alpha just to see where they max. For the most part, the core of the value is where the minimal error rates are at. In the case of figure 5, proportion to scale, it's a little bit off. The other major difference between the two is that I show error rates below 1. These error rates are slightly above 1, but you can kind of see that around the .3 range, which is what he mentions in the paper. They're very similar. Another thing I tried to do is to animate the differences between different alphas throughout the training sets just for troubleshooting purposes. The scale doesn't make sense here, but if you remember the original .1 training set, it ended up just above .2 error rate, and so the distribution is just widened out a little bit, but it matches the same curve. At .3 alpha, the error rates are significantly higher.